Hello and welcome to Agile TD Mondays. Today with Joshua Lewis, who will talk about a model that provides better guidance around automated testing. But first, you can still register for the 9th edition of the Agile Testing Days. Don't forget to register, have a look at the program, and experience the Agile Testing Days with us. Go to agiletestingdays.com and learn more about the conference. And now to you, Joshua.
Hi, everybody. Thanks very much for having me and for the opportunity. I really appreciate it. It's great to be with you all. Just a very quick introduction. I'm a Agile and developer coach with a history of software development. You can find me, there's my email address, and my Twitter is on the slides there. And as has been mentioned, I'm going to be talking about a model which I've developed, which helps development teams make better decisions around the kind of testing, automated testing that they do. So a common thing that I've noticed in a lot of Twitter and in my experience is this kind of idea of, we've got a lot of unit tests and our units are working as expected, but we don't have a lot of information about how our system as a whole is working. This is a scenario that's given me issues in my experience as a developer in the past. And I think it's quite a common thing. And the reason why I say it's quite common is that there's quite a few funny and interesting memes hanging around on the internet. So this is one of my favorites. This is one of the earlier ones. Another more recent one is this one with the automatic doors and the gates, which I quite like. That the units are working as expected, but the whole system as a whole isn't working as expected. Another example. So what these memes and these tweets telling me, and what I've experienced, is that our approach to deciding how we go about our automated testing is flawed. That there's a gap somewhere. So I'd like to take a little bit of a deeper look at some of the models we use to inform our current thinking and how we go about figuring out what kind of tests we should be writing. So this is the testing pyramid, which is at the moment, from what I've experienced, the most common model available that provides guidance around what tests we should be writing. This model is originally from Mike Cohn's Succeeding with Scrum book, and it talks about unit testing at the bottom, kind of the red area here, system or service or integration tests over here, and the last little bit on top of the pyramid is a UI or end-to-end based test. And this model is really about the relative ratios of the tests we should have. So what it says is you should have lots and lots of unit tests and quite a few system or integration or service level tests, and not so many UI or end-to-end tests. The problem with this is that I believe that this model leads us to flawed thinking and to flawed practices, as we've seen with the tweets and with the memes, and something that I've noticed in quite a lot of my coaching and development work. So let's unpack this a little bit. So I believe this model is obscuring a lot of the trade-offs that teams should be making themselves. So it's obscuring some of the critical thinking that teams should be doing. So the problem with this model is that it says that you should have lots and lots of unit tests. The problem is if we're missing information about how our system as a whole behaves, then having more unit or component level tests isn't really going to help. We can add more low-level tests which test individual modules, but we're still not getting feedback about how our system as a whole behaves. We really need to be focusing towards the top of this pyramid to be getting that kind of information. So in my opinion, there's two things that we know. So the first thing we know is that the testing approach is flawed, and that this model says we should be focusing our automated testing efforts at the unit level. Let's unpack that a little bit. the reason why in his book, Mike Cohn goes into kind of promotes this model and he talks about it is mainly for speed of execution. So typically, these kinds of automated tests that we'd find in this area at the bottom of the pyramid are very fast to run, give us very, very fast feedback. And that's why they're promoted as you should have the most of these. We want very, very fast feedback, and we generally have to wait longer for feedback from these higher types of tests. He also talks a little bit about granularity. So when we have a failing test, how easy is it to detect where that flaw is in the software? And I'll come to that a little bit later. So I'd like to ask, so this model is focusing on speed of execution, speed of feedback. But if our approach is flawed, then maybe we should be optimizing for other things. So I like to take a step back and ask the question, why do we test? And typically we test because running our tests generates feedback, gives us information about the state of our software. Testing is a feedback loop, right? We're exercising some parts of our software, we're getting information back, and we're using that information to form some kind of opinion about the quality of the software. So our testing efforts and the investments we put into a suite of automated tests should really be guided by the feedback that we need about the software. So if we have a gap in the feedback, we should try and aim our efforts around that, trying to close that gap. That's one of the reasons why I don't like the test pyramid. I think it's a great model, and it sounds like I'm picking on it a bit, but I think it was great when it came out, but I think that it obscures a lot of the trade-offs, and that has become problematic in 2017. So one of the reasons is that the test pyramid doesn't take into account what gaps we have in our feedback. So if we have a gap in feedback at the unit level, great, let's create more unit level tests. If we have a gap elsewhere in our feedback, and unit tests aren't going to solve that problem or close that gap, then we should probably not have more unit tests. So our optimization decision, so remember that the pyramid emphasizes speed of feedback. We're emphasizing for execution speed and speed of feedback. In my opinion, our optimization decision should rather be based on what feedback we need, i.e. what feedback we're missing, what gaps we have in this information about our system. So that raises the question that if we're not optimizing for speed, what else could we be optimizing for? And this is really where the test trade-off model starts to become relevant. So what I'd like to talk about next is what trade-off decisions are involved in figuring out what kind of strategy we should have for our investing in an automated test suite. So I want to start off with 4 dimensions, 4 trade-offs that I think are the most important. And those are speed, depth, granularity, and variation. Let's talk about each of those one at a time. So speed, how quickly does the test complete, or how quickly does the suite of automated tests complete? So how long do we have to wait until we get information about our system? So ideally, we'd like each test to run as quickly as possible so that we get the feedback as quickly as possible. The longer we have to wait for the feedback, the less frequently we're going to be running the tests, to the point where a lot of development teams, because in the past their tests took so long to run, they actually stop running them and they become more of a liability than an asset. So speed is quite important, and I think speed is probably it's certainly emphasized by the pyramid, and I'd agree that it's probably all other things being equal, probably the most important dimension. Next dimension I want to talk about is depth. So how much of the system is exercised by this test? And when I say how much of the system, I mean almost like a vertical slice of the stack, from top to bottom, user interface, middleware, persistence or data access. How much does this particular test exercise? And one thing to realize about depth is that the deeper the depth, or the more of the system exercised by a particular test, the more confident we can have about how the system as a whole behaves, right? So as shown by those tweets, we want to be confident about the behavior of the system as a whole. And in the ideal case, we'd like each test to exercise as much of the system as possible. The next dimension I want to talk about is granularity, and the concept of granularity is related to this idea of triangulation. So when a test fails, how easy is it to find the flaw or the defect in the code being tested? When a test fails, we want to know with as little effort as possible where that flaw is, so that we can spend the least amount of time trying to find it and fix it. Okay, so that's where granularity comes in. So granularity is related somewhat to depth, which we'll get into in a little bit. The last dimension I want to mention is variation, and this dimension is slightly different. The previous three dimensions were related to a particular test or a suite of tests. Variation is not so much a characteristic of the tests, but is more characteristic of the code base that's being tested. And variation represents how many near identical variations of the test there are. For example, in a system with lots of inputs or lots of possible states, there can be a large number of combinations, lots of different paths that can be taken through the software. And we want to be able to, ideally we want tests that will cover each path or each variation. So this is where variation comes in. So in the ideal world, we would want to maximize each of these dimensions. So we would want to have tests that run very quickly, exercise the whole system, include all variations, and also provide a good granularity, so that triangulating flaws isn't as much of a problem. Okay, so just to repeat that, we want all of these to be maximized, fast tests which cover the whole system, easy to find flaws, and we can cover all variations of inputs. Okay. Unfortunately, this is the real world, so we can't maximize all these dimensions at the same time. So this is where life starts to get interesting, right? Because these dimensions are not independent, they are related to each other. So the first relationship, which we're all quite familiar with, I think, is the relationship between depth and speed. So typically, the more code that is covered or exercised by a single test or a particular test, the slower that particular test is to run. Right, so there's an inverse relationship, and that's signified by the minus sign over here, that as depth increases, speed decreases. Okay, so if we're optimizing for one, then we're going to lose on the other. Okay, and this holds particularly true if architectural boundaries are crossed. So if we're hitting a network, if we're hitting input-output systems, etc., etc. The next relationship is between depth and granularity. Similarly, the more code covered by a particular test, the harder it is to find out where a particular flaw is in the software. All right, so the test fails, now we need to go and figure out where the defective code is. The more code being tested by that test, the harder that is to do. So again, an inverse relationship between depth and granularity. So as the depth of the system covered by a test increases, the granularity decreases. So that's also an inverse relationship. So this is the full causal loop diagram showing all four dimensions. So just to go through quickly, as we increase depth, we decrease the speed of a particular test. As we increase depth, we decrease the granularity. Now, an interesting relationship here, as the granularity of a particular test decreases, typically the speed increases, right? And that's where there's a plus sign here. Now, variation is an interesting one. If we have a system with high variation and we want tests to cover all possible variations, that means we're going to have a lot of tests, right? And that's why there's an inverse relationship between variation and speed, purely because of a volume, right? So if we have high variation, we're going to have a high volume of tests, which means generally the suite of tests will be quite slowly. And this dashed line here basically means because high variability or high variation has a negative impact on speed, we will typically decrease the depth of those tests so that we maintain speed. And that's why there's this dashed line here. And the idea behind this model is to start exposing what these trade-offs are, what these dimensions are, so that development teams can start making better decisions. So for example, if you want very, very fast feedback, you will probably not be able to maintain particularly high depth or a large amount of variation. Conversely, as we saw in some of those tweets, and in my experience, if we're lacking confidence or feedback about the system as a whole, well, we know that if we increase depth, we're going to decrease speed. And that's what the pyramid says. The pyramid says optimize for speed and don't worry about the depth. However, if we want to optimize for depth, we want to optimize for feedback about the whole system, we're probably willing to compromise a little bit on speed, and we're probably willing to compromise a little bit on granularity, and we might not test for every single variation. We might choose a few key variations of inputs because what we're really optimizing for is feedback about the system as a whole. And that's kind of how to use this model is, depending on what you want to optimize for, that will tell you your entry point will give you the dimension you should optimize for, which tells you what you should compromise on. So if you want to optimize for speed, by all means compromise on variation and depth. If you want to optimize for depth, well, you might need to compromise on speed and you might need to compromise on variation. And that's for a particular level, right? You can have different, you can use this model, choose different values for this model, different parameters for different levels of testing in your system. But that's kind of the idea behind the model. So again, to reiterate, expose the dimensions, figure out the relationships between them, and then provide teams with guidance on, well, what are you optimizing for? Eyes wide open, what are you going to most likely compromise on? And that's the model. Those are the dimensions, and that's the relationship, and that's how to use it. And this is pretty much the first iteration of this model. It's still in its early days, and for me, the next steps are to try this out in the field and to hopefully get other people to try this out in the field and give me their feedback. And I expect over time, more dimensions will be added, and we'll figure out the relationships between the different dimensions. Because, as I mentioned earlier, I think these certainly aren't the only 4 dimensions. I think these are probably the most important 4. But I expect this model to evolve over time. Thank you very much for listening. I think we've got a little bit of time for questions, if I'm not mistaken.
There is no relationship between variation and granularity. Couldn't you find any relationship, or is this completely out of?
I will say at this point, I don't know if there is or if there isn't. I'll probably need to think about it a little bit more at this stage. I wouldn't be surprised if there is a relationship. Yeah, it's just at the moment in this iteration, I haven't put in that relationship yet, but I wouldn't be surprised if there is one.
Okay. You said when you have increased depth, then you decrease the speed. So can you, in any form, in another form, increase the speed? So without having a too large impact on depth? Is there a possibility yet, or?
So for me, this relationship, which kind of underpins a lot of thinking up until now, especially like, for example, the pyramid, for me, this is the most contentious relationship. I think that this relationship used to be incredibly important, but I think with a lot of advances in tooling and computation speed, etc., that we have now, I don't believe that this is as true as it used to be. I think there's, for example, I've got a bit of experience, and I've heard of a lot of other teams, for example, including live databases and front ends in their test, in the automated test, in which case you get almost 100% depth while not compromising in speed. And there are, for example, I've worked in the .NET stack. There are tools, for example, the Owen test server, where you can spin up a full web server and hit it with HTTP commands, for example, but it doesn't go over a network. It doesn't hit a network boundary. So you're still communicating in HTTP, for example, but you're not getting that architectural boundary performance hit. So I think over time this will become less and less true. I hope that'll become less and less true. So for me, as I said earlier, this is contentious, and I expect this to change.
Thank you very much. On October the 9th, Claudia Bardell is going to talk about mind maps and how they are used to support exploratory testing. So tune in. Thank you, Joshua, for
My pleasure.
taking the time and for sharing his knowledge. It was a pleasure to me.
Great. Thank you very much.
Bye.
Bye.
Bye.